Today's lesson is the first in this new unit, which encompasses the topic of transformations. If you stop for a moment and think about what does it mean for a geometric figure to be transformed, the word transformed, like you saw in the movie The Transformers, means to change. Now, how can I change a figure? Well, I can change it in a multitude of ways. I can make it bigger, I can make it smaller. I can move it. I can spin it around, I can flip it over. And we're going to go through in the coming lessons each of these types of transformations. However, if you look at today's goal, what we're specifically going to address is what's called a translation. And we're going to understand what a translation means, and we're going to understand how to translate a figure in the coordinate plane. So let's just take a look at the three examples below. I'm going from one figure to the next, and it really doesn't matter all that much which one is going where, but there are directional arrows to show us. How did I go from the L to the new L, or from whatever this figure looks like, this looks like something in the inner ear, to the next one? Or how did I go from triangle ABC to the new triangle ABC, which we'll talk about how that is. Well, if you think about it, all I did was slide my figure from where it was to where it now resides. Okay? And that's the word that we're going to be focusing on or talking about a little bit more, which is slide. So let's get into what we're going to cover today. A transformation is, and I'm just stopping to pick up the writing. A transformation is a change made to the location or size of a figure. And it can actually be both, location and size, which we'll see later on. A translation is a specific type of transformation. So a translation is a transformation in which each point of a figure moves the same distance in the same direction. Okay? The notation that we use, we say we have an original figure and its image, a before and after. So if the original figure is A, we call its image A prime. That's what the single apostrophe stands for, prime in math. Or we can also say A, F of A. Okay? It's just notation that is used to indicate which one is the before and which one is the after. Okay? So, let's take a look at the first example. Describe in words how we went from the original triangle where A is located, here, to its image, A prime. Think of moving. When you're moving in the coordinate plane, you move either horizontally, right and left, or vertically, up and down, because I can count those points. We do not move diagonally. I can't count points diagonally. Okay? So, how did I go from A to A prime? Well, I went 1, 2, 3, 4 units to the right, and then I went 1, 2, 3, 4, 5 units left from the original point to get to the new point of 1, 3. Another way to look at it is I started at -3 for the x coordinate, and added 4 to it to get the 1. And I started at -2 for the y coordinate, added 5 to it to get to the 3. Okay? Now, let's get into some more of this coordinate notation. And all we're talking about is a way for us to tell you that what we want to do is take the original figure and slide it over somehow. So, you can describe a translation of each point by using coordinate notation. Meaning, I'm going to take the x coordinate and add some number to it, and that could be adding a positive or a negative. And then I'm going to take the y coordinate and add some number to it, either a positive or a negative. Okay? So, A tells me how many units to move a point horizontally, and B tells me how many units to move a point vertically. A is associated with x, B is associated with y. In the example on the right, I took the original point for x and y, and you can see I moved 1, 2, 3, 4 units to the right and 1 unit down. Now, move the point to the right if A is positive, and to the left if A is negative. And then move the point up if B is positive, so B positive, up, and down if B is negative. So how would I write the rule for here? I moved 4 to the right, so I added 4 to the x, and I moved 1 down, I subtract 1 from the y. So let's take an example for you to work on. You want to graph a triangle, or draw the graph of the triangle ABC. So A is -2. I start at the origin, I go 2 left and 1 up. That's A. B, -1, 4. And C, 0, 1. So there's my original triangle. The rule tells me to add 4 to x and subtract 5 from y. Now, excuse me, my preferred method is to take the original triangle and move the points. So I'm at A, I count 4 to the right, 1, 2, 3, 4, and 5 down, 1, 2, 3, 4, 5. There is A prime. I do the same thing with B. 1, 2, 3, 4, 1, 2, 3, 4, 5, B prime. And then C, 1, 2, 3, 4, 1, 2, 3, 4, 5. And then just connect the dots. Alternatively, you could have done it mathematically. This rule is telling me to add 4 to the x-coordinate and subtract 5 from the y-coordinate. So I could have figured out the new points first. -2 plus 4 is 2. 1 minus 5 is -4. -1 plus 4 is 3. 4 minus 5 is -1. 0 plus 4 is 4, and 1 minus 5 is -4, and then plot the points afterwards. I find it easier to move and figure out the points. Either way is fine. What you will notice is triangle ABC moves 4 units to the right and 5 units down. Now, I want you to see the picture before we get into the notes on the next page. Is there any difference between ABC, triangle ABC, and its image A prime, B prime? Meaning, is the length of AB and A prime, B prime any different? Is the measure of angle A and A prime any different? Is the perimeter or area of the triangle any different? Hopefully your answer to all of these questions is no. So, what are my properties of a translation? There are 3 of them. A translation maps, meaning coordinates from one to the other. Lines to lines, segments to segments, and points to points. Meaning it just matches up all of the corresponding pieces. Distance is reserved. No period. So let me get rid of that. Since the distance between any two points and the distance between the image of those points is the same. So as I said in the one example before, the distance from A to B is equivalent to the distance from A prime to B prime. And then the last property, a translation preserves angle measure. Meaning whatever the measure of each of the angles of that triangle are, A, B, and C, they are the exact same as the measure of A prime, B prime, C prime. Okay? Rigid motion. Well, if you think of what the word rigid means, kind of like stiff, okay, frozen, rigid motion, which is also called an isometry, fancy math word, moves the points in a rigid or stiff fashion. Nothing changed in the figure. Before and after was the same. It would be like, you know, one of those before and after people going on a diet. They look the same after as before and sue to get all their money back. So, is a translation an isometry? Yes. There is no change in the figure. Size and shape. Okay? Now, just to introduce a couple of other concepts. In math, we have what's called a vector. A vector is a segment in our plane. Plane is just 2 dimensions in math. So the way I would draw a vector is I have a beginning point or starting point. I'll call it A. And B is my ending point. The reason I have an arrow is the arrow is telling me the direction I'm going. So here I went right and up. And we can use vectors to help us translate figures by it telling us distance and direction. Finally, let's say I have a line and I want to translate it. So I want to move it, let's say, to the right and up. Well, if you take a look, the relationship between these 2 lines are that they are parallel, meaning never intersect. So one result of translating a line is I create a second line that's parallel to it. Another possible result is I can take this line and I can extend it out, meaning I just went in one direction that way. And that's what's called So, or the lines can coincide, which means I just extended it. So, to summarize, what we covered today was a transformation that was specifically a translation. And what we did is we took the original figure and we moved it via sliding it in the coordinate plane. We don't change its size or shape or anything of that nature.